Okay, today we're looking at a new topic. It is network flows. There's going to be 4 videos in this topic, and today I'm just introducing what network flows are and how to get a flow through a network. So what is a network flow? Well, essentially we start with a network. It's got a series of nodes and arcs. Usually they're directed arcs, which means they have little arrows on them. And then there are numbers on each of the arcs. Now, in a network flows question, the numbers on the arcs represent what we call the capacities of the pipes, and the arcs themselves are pipes. So there is an example of perhaps a network flow network. And there will be numbers on all of these arcs. So I don't know, 5, 6, 9, 7, 15, 20, 17. I'm just making them up now. 20, 5, 4, 3, 7, 8, and 10. Why not? Okay, so there's my flow. So there's my network, and the question is, how much flow can I get from the start node to the end node with those capacities in place? Oh, I missed one. 12. So there'll always be one start node. We call this the source, and in the next video we'll have a look at how we deal with situations if there's more than one source. And there'll always be one sink node, which is the end node. We call this the sink. And the rule is that once you've got your flows through the network, then if an amount of flow enters a node, that flow must also leave that node. The only exception is the source node that can produce fluid or whatever you're modeling in this network flow, and the sink can take it. It doesn't need to push it back out again. But every other node, like for example this one here, if I have 20 flow going into it, so if I use the full pipe capacity going into this node, then the sum of these 3 flows have to sum to 20. Okay, I can't have flow accumulating here, that is if flow in is greater than flow out, and I can't have flow being produced here, that is if flow out is bigger than flow in. We'll have a look at some situations where not all arcs are directed, and there's also some various other little tricks coming up along the way, but there'll be lots of examples coming up in the next few videos. So in this video, we're just going to look at getting a flow through the network. Okay, so let's have a look at a fairly simple case to start with. So this is my first example, and it's only got 6 nodes. It's a relatively small network flow problem. In fact, you'll probably be hard pushed to find a smaller one. Most network flow questions by the time you get to the exam will be kind of at least twice the size of this. What we've got here is we've got one source and we've got one sink. And then we have pipe capacities. So this pipe here from S to A can take a maximum of 7 flow units, which could be, I don't know, litres per minute. It's some kind of volume per unit time. So litres per minute would fit there. But perhaps it could be modelling traffic flow, so cars per hour or something like that along various roads. But usually we tend to think of these as being pipes with fluid flowing through them from the source to the sink. Okay, so the method I'm going to apply to find what flow I can get through this network is called the augmented flow method. Now, you don't need to have a particular algorithm to solve these problems in modeling with algorithms. So if you can just spot a flow, then great. But the augmented flow method will allow you to have a methodical way of finding a flow through a network. So what the augmented flow method does is you keep looking at the network and you keep adding flows through them. So I'm going to use a blue pen to represent my flows. At the moment there's no flows. All of these numbers are the pipe capacities. That's the maximum amount of flow I can have per pipe. Okay, so let's have a look at this route here, from S to A to C to T. That is one path that takes me from the source to the sink. So I'm just going to write SACT. And if I'm going to push fluid through that path, the maximum amount of fluid I can push through that path is going to equal the minimum number on that route. So in this case, that's 4. So 4 litres per minute, I could push through that route. So 4 is less than 7, so that's fine. 4 equals 4, so that's fine. And 4 is less than 8, so that's fine. So I'm going to push 4 units of flow through that route, which means this pipe now has 4 units of flow through it currently. This pipe has 4 units of flow through it currently. And this pipe has 4 units of flow through it. Okay. And I just keep doing that with different routes until I cannot add any more flow. When a pipe has reached its capacity, so in this case we've got a flow of 4 in a pipe which has a capacity of 4, I'm just going to shade it out and I'm going to say that this pipe is saturated. All that means is the flow through the pipe is equal to the capacity of the pipe. Okay, so I can't take any more. Saturated. Okay. All right, let's try a different route. So let's continue with S again. So I can go from S to A, and then I can go down to B, and then I could go up to C, and then down to T. There's no exact science here. It's not an algorithm. It is a method. We've got S, A, B, C, T. That's got 3 units of space left. That's got 2. That's got 6, and that's got 4 units of space left. The smallest of those 4 numbers is 2, so I can only push 2 units of flow through that route currently. That is now going to go up to 6 units of flow. That is now going to be at 2, so that is saturated. That's going to go from 0 to 2, and that is now going to go up to 6. Okay, so I've now got 6 units of flow through my network. I cannot up this arc anymore. I cannot push more fluid through this pipe because both of the pipes coming out of A are saturated. So if I push another unit of flow through SA, there's nowhere for it to go. So I've now exhausted how much flow I can push through SA. So let's move to SB. Okay, so I can do SB to D to T. So SB to D to T. That's got 5 units of space, that's got 3 units of space, and that's got 4 units of space. The smallest of those numbers is 3, so let's put a unit flow of 3 through that route. So that's now at 3, that's now saturated at 3, and that's now got 3 through it. And is there any other flow I can add to this network? Yes, there is. Can you spot it? I could take the route S to B to C to T, and that's another route. That's got 2 units of space, that's got 4 units of space, and that's got 2 units of space. So the smallest of those is 2. So if I take the route S, B, C, T, that's can give me another 2 units of space. That's going to go up to 5. That's going to go up to 4. That's going to go up to 8. That means this pipe is now saturated, and this pipe is now saturated. Okay, I cannot add any more flow through this network. Okay, we've already said that 6 is the maximum I can push from S to A because A can only take 6 out of it, and SB is now saturated at 5, so I can't push any more through that pipe either. So there's no more flow that can be added to the network, and the flow is represented by 6, 5, 2, 4, 4, 3, 8, 3, and I've put nothing through the pipe DC, so I'm just going to pop a 0 there. So it's got no flow in it. And then the answer to the question, which is what is the maximum flow through this network, is the sum of these 4 numbers. So 6, 7, 8, 9, and 11. So 11 units of flow. And if there were units given in the question, it would be a good idea to give your answer in terms of those units. For example, litres per minute. Okay, so that was a fairly simple example. But you can see how I have augmented the different flow routes through this network and then yielded my answer from that. Okay, let's try a bigger question. Same principle. I've got one source, usually, hopefully you noticed, usually denoted with the letter S, and one sink, which would have been used the letter S, but S is already taken for source, so we tend to use the letter T for sink. That is just common practice. Okay, S for source and T for sink. Okay, so let's apply the augmented flow network to this. So let's have a look at different flows. different routes to get from the source to the sink. Don't forget, all of these numbers that are currently on the arcs are all pipe capacities, and I am looking for what flows I can push through the pipes. The flows will be listed in blue. Okay, so let's have a look at this route first of all. SAET, it just goes along the top of the network, nice and easy to spot kind of what flow I can push through there, and the smallest of those three numbers is 90. So I'm going to push 90 units of flow through that route. That means that then this pipe is saturated. Put a squibbly line on it. And I'm just going to jot under here my route to SAET, and that is 90 units of flow. Okay, is there another one? Well, let's go around the bottom of the network. So I could go down here. SCGT. SCGT, and the amount of flow I can push through that is going to be the smallest of those three numbers, which is 70. So then I'm going to push 70 through there. So that's now saturated. That's now got 70 through it, and SC has got 70 units of flow through it. Okay, another route. Let's try. Well, I can't push any more into E because the pipe out of E is full. So I can't push any more along this arc or this arc, which means I can't put any more into A because that's the only one coming out of A, so therefore that can't have any water through it, and that can't either. So actually all of these are already written off. So I've only got these two now to consider. So I could send some flow this way, S to B to F to T, or perhaps I could go from S to C to B to F to T, or I can come down this route as well. So there's lots of different options available to you, and there isn't a hard and fast rule as to which you choose next. You just keep adding flows until you can, or until you've reached, until you can't add any more, essentially. So let's just go right through the middle of the network. So SBFT, so let's go drop this down here, SBFT, look at these numbers here, we've got 60, 40 and 50. The smallest of those is 40, so therefore that is going to be the flow I'm going to push through this route. So that's now saturated at 40, that's got 40 through it, and this has got 40 through it. Let's try and saturate this one, so I need to get 10 more. So I can come down here, and then up, and then in. So SBDGFT, that would be a route. I can push 10 through that, which will saturate that pipe. So I'm just going to jot that route down. So that's SB, I'm going to go down this way now, to D, to G, and then back up to F, and to T. Essentially, I'm using this route to bypass this saturated pipe. I could push 10 units of flow through there, because then that would be saturated at 50. But also, this one would be saturated at 10. I've pushed 10 up through there, I've got 10 through there, and I've increased that by 10, so that's now 50. Okay, there is no other route now I can take to get from the source to the sink. I have to pass one of these 4 saturated pipes, so I can't push any more flow through any of those pipes. So I cannot add any more flow to this network. So that is now the maximum flow. And quite often in an exam setting, there would be a copy of this network, and you would write down on all the arcs what the flow values you've chosen are, and the flow values are the one in blue. So 90, 50, 70, 90. And it's going to pop the zeros on, so some arcs I didn't use, 0, 0, 0, and 0. So you would copy those numbers across to the answer network. And then to get the flow, you just add these numbers up. So we've got 100, 210. There we go. So that is the maximum, it's the maximum flow through this. We haven't proved that, we'll come to that in a later video, but it is the maximum flow. You can't push any more fluid through this network. Okay, and example number 3. Okay. Now this one is a tiny bit different to the other two in the sense that most of the arcs are not directed. That means fluid, in this case, can go either way. So we could have 20 units of flow going from D to G, or we could have 20 units of flow going from G to D, or anywhere in between. So it's just a few more routes that you need to consider to get the optimal flow through this network. But the principles are exactly the same. We're going to use the augmented flow method to get a flow that goes through this network. Start from the source, go to the sink, which, as usual, is labelled S and T. So we've got the source here is S, and the sink over here is T. Just to clarify, a source node is a node which only has arrows coming out of it, and a sink node is a node which only has arrows coming into it. Okay. Right, so let's just consider around the top of the network first of all. So SACFT. So let's drop that route down. SACFT. What's the maximum flow I can push through that route? Well, it's going to be the minimum of these numbers, so 150. So let's put 150 units of flow. And now, because there's nothing directed, I'm going to put little arrows on them, just to indicate that I'm choosing the flow direction as well. The ones into the sink and the ones out of the source are already directed, and that's because the source can't take flow and the sink can't give flow. So by default, then they have to be those numbers, that have to be those directions. Okay, so that one is saturated. I can go around the bottom of the network. So 170, 150, 90, and 100. The smallest of those numbers is 90, so I can push 90 units of flow through that route. So S, B, E, G, T. That's going to be a 90. Pop a 90 there, a 90 there. This one is saturated. Can't push any more through. That's a 90, and I've got 90 there. Okay, there is still more flow I can push through this network. So I've not used node D yet. So let's go from S to A and then to D. And then where can I go from there? Well, if I go up there, I've got a limit of 10. If I go down there, I've got a limit of 20. So in fact, no, I've got a limit of 10. So whichever way I go, I can push 10 units through this route, but this doesn't overly matter. So I'm going to go from S to A to D to F to T. So S, A, D, F, and T. So S, A, D, F, and T. I'm putting 10 units of flow through there because in doing so, that saturates that pipe. That's now gone up to 160. That is gone up to, sorry, that's the capacity. It's gone up to 10. That's gone up to 160. And then I can do the other route, which I mentioned. If I come down to G rather than go up to F, I can push another 10 units of flow through. So that's still SAD, but this time instead of going up to F, I'm going to come down to G, and then I'm going to go into T from there. I've got 20 units of flow available here, 40 here, 20 here, and 10 here. So the smallest of those is 10. That's going to go up to 170. That's going to go up to 20. That is now got a flow of 10, which is going that way, and that's going to go up to 100. So that is now saturated. Okay. Is there any more flow I can push through this network? Well, it looks like I can bypass both of these saturated pipes by bringing flow in up around to C and then back down to the sink. So I've got 10 units of flow available in pipe CF. So I could come from D up to C and then across to CF and down into the sink. As for where the flow comes from, well, I can either go from the source through A or from the source through B. It doesn't matter. With these questions, they have multiple solutions. All of them are equally valid. So let's just go up to A. So I'm going to go from S to A, down to D, up to C, across to F, and then down to the sink. So that's going to add a flow of 10 because there's 10 left in this pipe, and there's also 10 left in this pipe as well. So that's now going to go up to 180, which means that is now saturated. That's now going to go up to 30. That is going to have flow in it now going upwards. That is now going to be at 160, so that is now saturated. And that's going to go up to 170. Okay, we'll notice here that to get from the source to the sink, I have to go across one of these 3 pipes. All of those 3 are saturated. Therefore, I cannot add any more flow to this network. There's no way to get from the source to the sink without crossing one of those 3 arcs. So that is my maximum flow. I can't push any more through. So 250, 260, 270. 270 units of flow is the maximum for this network. Okay, right, so that is a method that you can use. Like I said, you don't need a formal algorithm or formal method for this course, but sometimes you will be asked to state a flow of a particular value through a network, and I do recommend this method. The important thing about this method is that once you've got all your flows down on your answer, all of the flows for each pipe must be less than or equal to the capacity of the pipe. Okay, it can't be more than the capacity of the pipe. And also, at each node, all the flow into that node must equal all the flow out of that node. If you followed the augmented flow method correctly, then that would be the case. So for example, let's look at node A here. My final flow is I've got 180 going into node A, and then I've got 150 and 30 coming out of node A, so that equals 180. So flow in is 180, flow out is 180. So therefore there's no net flow at A. If I look at D, I've not got an arrow on that one. If I look at D, I've got 30 coming in, and then I've got 10, 10, and 10 coming out. So therefore there is no net flow at D, which is what I want. You don't want any net flow at any nodes other than the source node, which is the only node where flow emanates from, and the sink node, which is the only node where flow collects. Okay, if you have any questions on any of those examples, then please just pop them in the comments below and I will get back to you. The next video we are going to look at is super sources and super sinks, and then we're going to have a look at cuts. Thank you very much for watching, and I hope you enjoy the next few videos on network flows.